Hope you all enjoyed the video recordings of the Kamailio world. So yeah, let's continue with my talk. I will talk about how to use Kamailio as a session border controller, but in difference to most other people are using, we try to do it in a stateless fashion. Why? I explain it in a minute. But first, after Daniel's perfect introduction, a few very short slides about who we are. So I work at Pascom, and here you can see actually our new office building, which we built in 2016 to replace our old building, which was essentially a converted private home. Pascom was founded in 1997. We started out as a PC and networking specialist, and just happened to create the first voice over IP, or our first voice over IP PBX in 2006. In 2016, we moved that system to the cloud, so that we also allow it to, or that we also directly support connecting to it over the public internet without any VPN and stuff like that. And as of today, our business focus has almost entirely shifted to selling that PBX system. A few words about me. I have about, including my education, I have about 10 years experience as a developer. Since 2012, I'm with Pascom. I'm usually not quite the specialist for the details of the SIP, because usually I'm more at the front end of our system, so more HTML, JavaScript, doing UIs and stuff like that. But sometimes I also dive into the backends and improve stuff there. Yeah, and also I'm a hobbyist photographer, and that hobby turned out to be quite useful, as you can see it with Kamailio World Recordings. Okay, so what do we do? We built the Pascom PBX. It's some kind of classic PBX system, especially suitable for some small to medium-sized businesses. So what we try to achieve is that we have many convenience functions and make it especially easy for administrators and end users to use and configure our systems, because you know, an Asterisk is a really great PBX server, but you require a lot of special knowledge to configure and to use its awesome features. And we try to automate that the way that you have a key-ready solution which you just can start to use. On top of that, we have also, which you can see, UC desktop client for all major operating systems, even with CTI functionality. So we also integrate with the classic desktop phones and voice over IP phones, and can remote control them, so to make it easier. So as I already mentioned, last year we built a multi-tenant cloud solution out of our PBX. So the goals was to be able to host multiple tenants, multiple customers on one machine to spare resources, so that you know that you don't need to fire up one virtual machine per customer, which takes up just way too many resources. And also we want to, at least in part, get rid of all problems regarding VPN connections. If some customer has, for example, he has two offices, one a main office where the PBX is located, and one branch office where a few people work, and then you need to get some connection, and sometimes it's quite difficult to get a working and reliable VPN connection here. Or also speak about like people who work in home office, they also want to phone and also want to use all the features, like being agents in a queue for taking the calls to the back office or stuff like that. So as you can see with the previous talk, with the Subvicious talk, it's quite important to focus on security here. And also, Ole, unfortunately, is not here anymore. He also talked a very important thing. If you can encrypt, do it. So we did it. We try to encrypt everything we are doing. So we primarily use zip via TLS, SRTP for all the media streams, and HTTPS management and provisioning, which is not important or not so much important in the context of this presentation. So where comes Kamailio into play in all of this? It's we are using a rather old Asterisk version, so please don't start laughing, but we are still on Asterisk 11, the certified branch. We are trying hard to move to a newer version until the end of 2017 before it goes finally dead. But still we have a lot of customers which like, yeah, let's call it stable versions, and so we need to maintain the older systems for quite some time. So we need to put something in front of the Asterisk, because with that old Asterisk version, and especially a very old libsrtp version, we had quite some problems, which even led to some crashes when you used an SRTP call with certain hardware phones. So our actual implementation looks like this. So what's called Cloud Stack is actually, let's say, one host system. So we have Ubuntu Linux as base for this. And on top of that, they are running multiple PBX instances as containers. And in front of that, we have one or more Kamailio proxies, which are used to terminate all the encryption. So within our own system, we trust ourselves. So we use UDP, RTP, and unencrypted connections also to be able to debug all of that stuff. So the big, and of course, I mention it again, to the front end, to the internet, we only have some protocols with an S in them, so SRTP, zip via TLS, HTTPS, everything. So the advantage of this is for most networking scenarios we implemented, you just need one external address, not multiple of them. But you have the advantage that every tenant, every customer can have its own Asterisk configuration, so its own IVRs, its own voice prompts, even some special Asterisk scripting and stuff like that. So we are able to highly customize the experience here, which is one of the key factors of our product, so that you really be able to customize it. So as I said, we tried, or we actually did implement it in an almost stateless way. So we don't manage registrations and stuff like that directly in the Kamailio. But we have an advantage for that. So the Kamailio container is very easy to update and even easier to manage, because you don't need to manage or care about that stuff at all. If you want something different or want a new version, you just throw the old away and use a new one. You don't need backups, you don't need databases, and you don't need to care about any persistent state. Okay, for that we need to offload all the registration to the Asterisk. And yeah, there was, if you have a persistent storage for the registration, you have also more routing information available in Kamailio, which we have not. And on the other hand, the second challenge, or the challenge which comes out of this, is how to route the zip package actually to the right Asterisk instance. How does the phone find the right Asterisk and back? So essentially, routing without state. Okay, some of you may now talk about RFC 3327, the extension header field for registering non-adjunct contacts. but the problem is it's only available in 12 and later, so we are out of luck. As I mentioned earlier, we want to upgrade to a newer Asterisk version, but we still need to be able to support the older systems for special use cases and just customers that just don't like to upgrade, but paying a lot of money for support. Okay, then we did some research, and at this point I want to thank Daniel a lot because he did a workshop with us and actually found a suitable workaround solution. So we encode all necessary information to route back in some extension, in some custom extension to the contact field. We call it XMD. And we encode the source IP, the source port, and the contact URI in a actually quite long hex string. It's cut off at the end of the slide. And the advantage of this is that we get the contact field back unchanged from the Asterisk. Actually, the code you're seeing here is the output of zip-show peers, or zip-show peer for that special peer of the Asterisk CLI. So we get that back unchanged, can decode it in the Kamailio and use it for the routing. So that problem is solved. So the next problem we faced was which container technology should we use? We had a long, hard look at Docker, but we finally didn't go for the Docker because it was just too much of voodoo for us. So you have all that stuff going on with fully automated networking, with these images which are available on this public registry, which is great if you just, for example, you want to run a test instance on some WordPress, you just type in Docker run some fancy WordPress container and you have it up and running within a few minutes. But if the problems start to begin, if you want to have a private registry because you don't want to push all your images to the public because they're not usable out of context and stuff like that. And also it's just hard to know what's really going on under the hood without reading all the Docker source code, which we honestly didn't want to do. So instead we opted for LXC, which was at that time the technology underlying of Docker, but since then they moved on to something different, and we are sticking still with LXC. Why? It's at the very basics of containerization, so it sticks to C groups to isolate the processes and resources of each container against each other. And on top of that, you have a command line interface and API, but not much more than that. You need to set up your own networking, which also gives you the control over the networking back. And also, you can define your own container image formats suitable to your needs and put your own metadata into it and everything, so that we can actually say, okay, this container needs certain configuration parameters, and then we can actually validate if the configuration is correct and all that stuff that was not easy to do with Docker, or downright impossible. Okay, this solution is now in production for a bit less than a year. And what our experience with everything? First of all, we love Kamailio. It's a rock-stable product. And okay, I know that all of you are very focused on performance, like, yeah, having 100,000 registrations on a Raspberry is no problem, and all of that, but that's not the most important stuff for us, because as I told you, we are focused on small to medium business, so something between 20 and 500 users per customer or something like that. And for the most important stuff for us is that Kamailio is a really great toolbox for everything around to zip. So when you need to fix something or improve the routings and all that stuff, it's really, you find something that helps you in Kamailio. But we really found out that endpoints prove to be a problem. So that is actually a picture of one of our testers' desk. So we really need to test a lot with different hardware vendors, with different endpoints. Usually, if you just plug it into something and use UDP and RTP and no encryption and nothing, everything works fine. But the moment if you switch the signaling from UDP to TCP or even TLS and switch the media from SRTP, you're faced with some buggy implementations, even in very recent devices which were launched in some thing 2015 and everything of that. So an example of that, we have one of the phone devices actually has the problem that when we're using encrypted connection to it, so you get the TLS server hello, then on Wireshark you can really watch, there are 4 to 5 seconds pause, so nothing happens. And then the client key exchange comes back and the encrypted connection continues like nothing happened. So we still don't know, we are in debugging of this problem at the moment. We still don't know what's really going on. But what we know so far is if you switch the encryption to RC4 only, then everything works fine. But if I use RC4, I can also use no encryption at all. So we need to find a different solution for this problem. Okay, the next thing is also very interesting. This is actually a Wireshark screenshot, actually 2 different. Can you see what's wrong with this zip package? Can any of you spot a problem in that package?
White space is at the first line.
Yeah. Okay, what happened? So we had this one zip-based stacked system, and it does what every good endpoint does in some sensible default configurations via UDP. It sends a keep alive package every 90 seconds to keep, to work around NAT, as usual. Its payload consists of some null bytes. Okay, so we switched that device to TCP and actually to a TLS connection. And it continues to send those keep alive packages for whatever reason, because in TLS you have a persistent connection and you don't actually need this. And Kamailio gets a bit confused on that and actually prepends these null bytes to the next valid zip package. So you get a keep alive and then the next options or invite or something comes in, and when it goes out of Kamailio in direction to the asterisk, the null bytes are in front of the actual zip package, and asterisk just says, okay, that's not a zip package, I throw it away, which results either in a lost call or lost registration and all kinds of trouble. All our debugging tools like sngrep and zipgrep, and even it was even not really visible in TCP dump, had left us there. So sngrep also just showed nothing, so no package, no problem. It just looked at the first moment that this device just omits some options or invite packages at some point. We had to switch, we had to build an extra test environment with a TCP connection instead of TLS, so that we are able to trace the complete connection when we were able to spot this problem. Okay, the actual solution was to explicitly disable the keep alive in the provisioning, but that cost us, I think, about a week of debugging until we found out. The next thing is we need to provision the endpoints. We have seen it in the OBHI workshop on the first day of the Kamailio World. It's really hard to get configurations out to endpoints via internet. Usually, at least our users are used to have, or are used to have their own voice network. So even if it's all Ethernet, you have an extra plug where you plug in your phones. And on that, you have also your own subnetting and your own DHCP server, and just can serve the option 66 with some nice provisioning URL in it. The configuration, the phone fetches its configuration from the server, and everything is fine. So if you move that to the internet or with some internet in between, you can't do that. It's, yeah, try to run a DHCP server on the public internet. Doesn't work that good. And yeah, for that way, we needed to find some kind of workaround, which is at the moment requires the user to power up the device, somehow find the IP address which it's got assigned to in his local network, open up the web UI, log in with the default credentials if he knows them, and copy and paste the provisioning URL, like you can see here, manually into the device. It's
use Zobi High, do it for you.
Sorry?
Use Zobi High phones. Do it for you.
Yeah, and yeah, that's not very user-friendly as you can imagine. So, and also at some point insecure, but we require some information to identify the device. Most of the devices are as friendly to send their MAC address actually within some HTTP header, most times within the user agent. So you can pass that header, identify the device, and put out the right provisioning. But that doesn't work always. We also had some kind of neat proxies, which then changed the user agent headers and removed stuff and all kinds of fun. So actually what we had here is we have somewhere in that URL, there's a MAC address encoded, but we try to encrypt the URL so that the possible attacker is not able to just, okay, that is my URL pattern, I just iterate over all the MAC addresses and try to fetch all the configuration which contains sensitive information like peer data, so you should do that. With that, it's not a real, like, you cannot decrypt the URL. This encryption here is just to protect against this kind of leeching attack. Okay, but as I said, the old DHCP solution is much more user-friendly. So we need to do something about this. What we're at the moment looking into is to have zip-based provisioning via Kamailio. I don't know if this is more fancy than diameter or not, but it's up to you to decide. What is this all about? A lot of devices send some half proprietary zip broadcast message when they boot up, which serves mostly the same purpose like the option 66. You can respond to that and actually send some provisioning URL. You see here containing a nice MAC address of one of our test system and a URL of one of our internal systems. And then it used that URL to fetch its actual configuration. It's nice, neat, but broadcasts also don't work very well via internet. What we're thinking about at the moment is maybe have some small little box which you can, some kind of Raspberry, which you can just put on the customer's network so that they don't need to interfere with his network configuration and don't need to require set up a DHCP server and stuff like that. So it has less impact, but also improves the usability. And for that, we also want to be able to reconfigure our Kamailio instances on the fly. So at the moment, if you have a configuration change in our container, you need to shut it down, change the configuration, power it up again. If you have TLS, if you have 500 TLS connections on it, that's not so good because you may lose calls, you may lose registrations. Again, we have some very, very intelligent endpoints which, when they lose the TLS connection, they just don't reconnect for 30 minutes. Great. So what we want to avoid restarting the proxy containers with Kamailio as much as possible. So, and also on the same hand, we don't want to have this SIP PMP provisioning feature available all the time. So because of security region, because anyone can send and broadcast, and we will happily maybe create a device object in our PBX and send out some default configuration with some peer in it, where you can then register to Asterisk and try some nice vicious attacks against it or something like that. So we want to enable to be able to reconfigure the Kamailio on the fly, but we are in a very early concept phase with this at the moment, so I can't give you any details about this. Any questions?
Thank you.
And now questions. Okay, one that back.
Hi.
Hi.
What I'd like to ask if you can elaborate a little on how routing works based on the information that is encoded in the contact ID when for example, request comes from an endpoint for the very first time into Kamailio, because as you said, Kamailio doesn't do database, right? So how does this request, how do you determine which Asterisk instance to direct this request to for the very first time?
For the very first time, I actually left out a bit of the presentation because for brevity, because we're already at 27 minutes. In the configuration we abuse the SIP domain configuration field of all the phones to put in the instance we want to connect to. So our instance has names like, it's customer name. So if, for example, Acme or 1&1 or something like that, and you put that into the SIP domain, and then you get the correct headers and can use that for routing towards the Asterisk. But for back, we don't have this information. So this XMD header, this XMD extension is mainly for finding the route back when the Asterisk does an invite to the endpoint.
Okay. Other questions here? Otherwise, I expect next presentation at the next edition will be about using Kamailio as a provisioning system for end devices.
Probably.
Okay, as we are already ready, thank you, Jan, and for the presentation especially.